The nematode worm C. elegans is a tiny animal. It's only 1 millimeter long, the size of a comma on a printed page. But it's a real animal. It moves around, it learns, it recognizes other nematodes, it interacts in social groups, and it forages. So it has a set of different behaviors that we can study. The advantage of this animal is that it's transparent, so that we can see the entire brain while the animal is behaving. We can see what happens in the nerve cells, and we can see how they interact with each other. And in addition, we can study the action of genes on the nerve cells in great detail. Every animal is born with certain abilities. Every animal is born with a nervous system that functions, that allows it to move around, that allows it to detect the environment and to respond appropriately. And these innate abilities are determined by the genes that the animal shares with its species. Now, these genes are not only shared in a species, but between species. So, for example, the genes that are used in the human brain, most of those genes are present even in the brain of tiny C. elegans. And that includes many of the genes that we think of as being involved in complex human abilities. So the genes that are altered in human diseases, like schizophrenia or autism, are, surprisingly enough, shared by the brain of the worm. Now, we are not guilty of anthropomorphism. We do not think that worms have schizophrenia. We do not think that worms have autism. But what we are guilty of is zoomorphism. We believe that the complex abilities of humans evolve from the simpler abilities of animals, and that we can study those simpler abilities and the roles of genes in setting those basic properties of the nervous system in C. elegans and try to extract from those principles of how more complex nervous systems work, so that we can point to a gene and say, aha, this gene is involved in making connections between nerve cells. That these connections are important for generating very precise relationships between nerve cells. And then many years later, other groups might find that these genes are altered in humans that have dyslexia. Now, worms cannot read, but by understanding that these genes affect the connections, we can look at the human disorder and say, dyslexia might have to do with changes in these very fine connections between nerve cells. That is the sort of analogy that we can use to move between, on the one hand, a very simple animal, through a gene, through the way part of the nervous system is built or it functions, and then think about how that might apply to the much more complex animals like humans, our genes, our nervous systems, and the different functions our nervous systems carry out.